Let's get into an application problem. So here we have an airplane that's flying on a horizontal path at a height of 4,000 feet, pictured here. At what rate is the distance S, so here's S, between the airplane and the fixed point P, this should be P, changing with respect to theta when theta equals 30 degrees. Express your answer in feet per degree. So as this plane is flying horizontally, I could imagine that this distance between this point is going to get a little shorter, right? As this gets closer and closer, the distance between the plane and P is going to get shorter. I can envision that. So I could imagine that my answer should be negative, right? Because the distance should be getting smaller. So the rate of change of the distance should be negative. So let's see if I'm right. So let's first create some connection between theta, S, and this fixed height of the plane. That fixed height isn't changing. It's flying at that horizontal path. But what is changing is theta, this angle, right? As the plane keeps flying, that angle is going to keep rotating with it, and this S is going to change, right? So these two are important variables in the equation we're going to set up. So what's the relationship between theta, 4,000, and S? Well, if this is an angle, 4,000 is my opposite side, and S is my hypotenuse. For right triangle trigonometry, I know that sine theta equals opposite, which is 4,000, over hypotenuse, which is S. So I can then rearrange this, solving for S, to say S equals, if I multiply S up here and divide sine, 4,000 over sine theta. 4,000 over sine theta isn't very nice. We usually use a reciprocal trig function there. The reciprocal of sine is cosecant. So this is really 4,000 cosecant theta. So now I have a function for the distance S in terms of theta. So as theta changes, my output is going to change, which is the distance between my plane and P. So as this degree changes, this is going to change based on this angle. So they're asking us to find the rate of change of S. The rate of change of S. Well, that is just ds d theta, or S prime of theta, right? Those are both equivalent statements, which is the derivative of this trig function. So that is going to be 4,000, which is my constant, multiplied by whatever the derivative of cosecant is, which from our first page is negative cosecant theta, cotangent theta. So now I can already see my answer is negative, which is what I hoped would happen based on my understanding of the diagram. So my answer is negative. So now I need to actually figure out what is this when theta is 30 degrees. So I've provided this special right triangle here for you. Ultimately, you should know these ratios in your mind, or have sine and cosine of 30 and 60 and 45 memorized, whatever works for you. So, but this is just helpful. So we are going to have S prime of 30, or the derivative with respect to theta at 30 degrees is 4,000. I'm just going to go ahead and move that negative up front. Now, what is cosecant of 30? Well, cosecant of 30 is just the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite, which is 2. And then cotangent 30. Well, tangent 30 is normally this opposite over adjacent, so cotangent is adjacent over opposite. square root 3. So s prime of 30 equals negative 8,000 square root 3. And since this is change in s over change in theta, well, s is in feet, and theta is measured in degrees. So if I wanted to write a sentence answer, I would say the distance s between the airplane is changing at this value, feet per degree, at the time that theta is 30 degrees. So sometimes you have to write your answer as a complete sentence.